Hello everyone. So today I'm back with a new video on NMR spectroscopy, how to analyze proton NMR. If you have not watched the previous series on proton NMR, please go to my playlist how to analyze proton NMR and you will see the details. So I was discussing about the practice NMR session. I was giving some structures, some chemical structures, and then I was predicting its NMR, and then I was displaying its actual NMR lab NMR data. Okay, so today I'll do the same thing on some more new examples from my lab data. So let's get started. Let me share the screen. So this is the practice NMR number 1 structure. As you can see from this structure, I have already discussed in details how to analyze proton NMR. If you have not watched them previously, please do watch them. You will get a very good idea on how to analyze the proton NMRs from the lab data, and also how to prepare the sample for NMR, which mistakes you should not do. I have explained everything in details. So let's start with this structure. So as I have already discussed that when we get any chemical structure and we try to analyze its proton NMR, we mainly look at the aliphatic protons and the aromatic protons, mainly the two types of protons. Okay, so the aliphatic protons, they have chemical shift between 1 to 5.5, and the aromatic protons, they have chemical shift between 6 to 8. Okay, so in this structure, let's figure out how many different types of aliphatic protons are there. So I have already marked them. So this is 1, 2, 3, 4, and 5. So 1 has 2 protons, 2 also has 2 protons, 3 has 1 proton, 4 has 1 proton. So this NH, I have marked it here. You may or may not mark it because these NH protons, they are a little tricky. Sometimes we see them in NMR, sometimes we do not see them. So we should not worry about this much because this sometimes has some chemical shift value around 5. Sometimes I see them around 7. So nothing is fixed. It depends upon the chemical environment. Okay, so these NH protons are a little tricky to figure out. The chemical shift value totally depends upon the chemical environment attached to it. Okay, and also like the NMR solvents, like if we use methanol D, you will not see this NH proton. But if we use CDCl3 or DMSO, something like solvent like this, you may see this NH proton. So I have marked it here. You may or may not mark it. Okay. And next, there is the number 5. So 5 has 18 protons. I have written it here. So this 5, it is actually a tertiary butyl group. So you must have known about the structure of this. 3 methyl groups are attached to single carbon. So this is the structure of tertiary butyl. So 3 methyl groups, that means 9 protons. There are 2 tertiary butyl groups. That means 9 into 2, a total of 18 protons. So all these protons we should see in our structure that will have chemical shift value between 1 to 5.5. And now let's check the aromatic protons. As I have already discussed it before, that these aromatic protons, they have, we do not look for its different type of aromatic protons, because their chemical shift values are very, very close. It is very difficult to distinguish them. So we just count broadly the total number of aromatic protons. So let's see how many aromatic protons are in the structure. So 1, 2, 3, 4, 5, 6, 7, 8. So there are total 8 aromatic protons, which has chemical shift value between 6 to 8. So this is the prediction NMR from the structure. Now let's look at its actual lab data. So as you can see from it here, that this one, I had said that 1, 2, 3, 4, and 5, they will have chemical shift value around between 1 to 5.5. So let's check. 1 is for 2 protons. So this is 1, and 2 is again, this is for 2, like this, as this is for 2 protons. And I have also mentioned, like these numbers you see over here, they are the integration number. In the NMR software, you will have this option to integrate each of the peaks. This denotes the total number of protons. Now, like this peak is for how many protons. We get this from the integration number. So in the NMR software, you will have the option to integrate the peaks. So these are the integration numbers, and generally we do not see it like a full number, like you will not see 1 or 2 or something. So if it is 1.9, obviously this is 2. So this is for number 1 proton, and then 2, this is also for 2 protons, and then 3, I know this proton, I know its chemical shift value because I have used this type of structure in many of my previous compounds. I know this has a chemical shift value around 4.5 or 4.2, something like that. So this is the 3. I know this is, you see, this is around 4.5. So this is for 3. And 4, as I had mentioned before, that this proton you may or may not see. Okay, so here I have used the solvent CDCl3. So as I said, in methanol D, you will not see it, but because this is CDCl3, we will see this proton. So this is at 5. It has chemical shift value of 5. Okay, so we have all of these aliphatic protons, and now, and this 5, these tertiary butyl groups, they have total of 18 protons, and they have a chemical shift value of 1.5. If you do not know like which functional group has chemical shift value of around which, please go to my NMR series playlist, and I have discussed the table which mentions everything, like which functional group has the chemical shift value of what. So I have precisely given the table. Please go to that table. Okay, so these tertiary butyl group protons, they have chemical shift value of 1.5, around 1 to 1.5. So you see this big peak. So this is for 18 protons. So it perfectly matches with our prediction NMR. Okay, now let's check the aromatic protons. So this region 6 to 8, so they are for aromatic protons. You see, I have integrated it together. So this is says 8.23, that means 8 aromatic protons. And also in our prediction NMR, we had 8 aromatic protons, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this perfectly matches with our prediction NMR. And also this suggests that this compound is pure because there is no extra peak. Okay, and we see some small peak over here. There are some solvent interference peak, I would say, because no impurity will have a chemical shift value around 0 or something. These are the solvent interference peaks. Okay, so this compound is pure. So let's go to the next example. So the same thing we'll do over here. We'll focus on the aliphatic protons and the aromatic protons. So I have also marked it here. There are 1, 2, 3, total 3 types of aliphatic protons. So one has one proton, 2 has two protons, and 3 also has two protons. Okay, so we also have NH over here, but I have not marked it here. As I mentioned that this proton you may see it or you may not see it. Okay, so we'll not just bother about this. So these three types of aliphatic protons are present over here, which will have the chemical shift value between 1 to 5.5. Now let's check how many aromatic protons do we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are total 9 aromatic protons which have chemical shift value between 6 to 8. So this is the prediction NMR. Now quickly check its lab NMR data. So this is the structure. As you can see, I have also marked it here over this structure. So this one, this has this is denotes for this one. So as I said that I know this type of proton in many structures. Sometimes it has a chemical shift value around 4.5, so sometimes it has 5.1 or something. It is basically within this region 4 to 5.5. Okay, so I have marked it here, and then 2 and 3, so they're perfectly matching. So these two protons, they are for 2 and this is for the 3. Okay, I'm sorry. So, and now let's check with the aromatic protons. So in the prediction NMR, we had seen that it has 9 aromatic protons, and it perfectly matches with this integration. It also has 9 aromatic protons. Okay, so here let's check which type of solvent I have used. I have used methanol D. So we will not see this NH peak over here, but this methanol D has solvent interference peak around 3.3 and 5.1. So what is solvent residual peak? So each NMR solvent will show some solvent residual peaks. I have discussed in details in my previous videos. Please do watch that if you do not know what is a solvent residual peak. Okay, so we will see this 3.3 and 5.1. These are due to this methanol solvent. So we'll not just will not integrate them. So 3.3 and around 5 or 5.1, these are the methanol solvent peaks. So we do not see any other extra peak over here. So this perfectly matches with our prediction NMR. So you will conclude that, okay, this compound is here and this is absolutely pure. Okay, now let's go to the next example. So we'll do the same thing. We'll look for the aliphatic protons and the aromatic protons. So here also we have 1, 2, and 3 type of aromatic aliphatic protons. So 1 is for 1 proton, 2 is for 2 protons, 3 is for 3 protons, and they all have chemical shift value between 1 to 5.5. And there are 1, 2, 3, 4, 5, 6, 7, 8, total 8 aromatic protons, which will have chemical shift value between 6 to 8. So let's check its lab NMR data. So we can see this peak at 5.1 for this one, and then we have this 2 and 3, which denotes 2 protons and 2 protons respectively. And also in the prediction NMR, we had 8 aromatic protons, and we can see the peak for 8 aromatic protons. So, and also this solvent is methanol D. So we'll see the solvent interference peaks at 3.3 and around 5. So these are the solvent residual peaks of methanol D, and we do not see any other extra peak over here. So this is also an absolutely pure compound. Okay, now let's check with the last example. So we'll do the same thing. We'll look for the aliphatic protons and the aromatic protons. So we have 1, 2, 3, and 4. Total 4 type of aliphatic protons. So 1, as I said, I have drawn the groups over here. These are the tertiary butyl groups, which I had shown in one of my structure, TBU. So I have drawn it over here. So you can see all these are these tertiary butyl group things. So it has total 3 3 3 3 3 3, total 6 into 3, 18 protons we have, and 2 has 2 protons, and 3 has 1 proton, and 4 has 2 protons. And I am not marking this NH proton over here. As I said, it may or may not appear depending upon the NMR solvent. Okay, now let's check how many aromatic protons do we have. So 1 2 3 4 5 6 7 8. So we have 8 aromatic protons, which will have chemical shift value between 6 to 8. Now let's quickly check its lab NMR data. So we'll first look for this big tertiary butyl group peak. So as I had mentioned it before, it will be here at 1.5. So this is for 18 protons. So this peak is here, and then 2 3 sorry, I have not marked it here. So oops. So this 2 is over here, and then 3 is over here. So I have not marked it over here because I know that maybe this one or this one can be the 3 proton. As I have mentioned it before, that this 3, it comes around 4.5. Okay, this comes around 4.5. So basically this proton is number 3, and this is 2, and this is 4. Okay, so this is 4 and this is 3. And then we have used here the solvent CdCl3. So we will see this NH peak. So as I said, that NH peak has chemical shift value around 5.1. So this peak is for the NH. Okay, so we have all of the peaks over here. So 1 for 18 protons, 2 for 2 protons, and then 3 is here. That is for 1 proton, and then 4 is for 2 protons. And then we also see this NH proton over here, that is around that has chemical shift value of 5.1. Okay, and we have 8 aromatic protons, but we see over here that is 10.21. So but we are using solvent CdCl3. So this CdCl3 has solvent residual peak at 0, 1.5 and around 7.1. So probably this extra peak is due to the CdCl3 solvent itself. So if we check this NMR in a different solvent, then we will be sure that if it shows 8 protons over here, if we suppose we are using this NMR in methanol D and we see this number is 8, then we can say this is absolutely pure compound because there is no extra peak. But we have used CdCl3 solvent, and this has solvent residual peak around 7. So we see 2 extra protons over here. So maybe these 2 extra protons is coming from the solvent residual peak. Okay, so in order to judge this, whether this is a pure compound or not, we should check this structure in a different solvent other than CdCl3, which doesn't have a solvent residual peak in this region. Okay, so these are the 4 examples I wanted to discuss today. So I will continue my discussion on NMR, and if you have any question, you can write in the comment section. I'll try to answer it. Okay, and please do like, share and subscribe to my channel, because this motivates me to make new videos, and you can suggest some new topic in which topic I can make videos. Okay, so thank you and bye bye for today.